Hello children, we'll be completing the remaining part of the mole concept. Now go for the example 9 on page 79. What is asked here? Calculate the total number of electrons present in 1.6 gram of methane. Like previous one, find out the molecular weight of the methane, which is 16 mu, and this equation is very important. 16 gram is equal to 1 mole is equal to Avogadro number. So you have ultimately 1.6 gram will have 6.022 into 10 to the power 22. Now 1 molecule of methane will have 10 electrons. How? Carbon has 6 electrons and 1 H will have 1 electron, so total 4 from hydrogen, and carbon has 6, so total 10 electrons. So 10 electrons, this 6.022 molecules will contain 10 into this many, that means again the Avogadro number is coming back. Now these are certain relations. Here it is GAW, that is gram atomic weight. Here it is GMW, that is gram molecular weight. However, I am attaching this relation, but I never suggest you to go through all these relations, that is you have to remember all this formula. I will tell only to remember these basic details which we had discussed till now, like this one. 1 mole is equal to molecular weight is equal to Avogadro number, and 1 mole of gas is 22.4 liter of at STP. If you remember these two basic equations, you can do all problems. But still, I have added certain relations so that you can be able to understand. Now go to your exercise 5B. There are hint to some problems like question number 10, which has appeared in ICSE exam 2017. Find out the weight of 22.4 liter of gas at STP, and that will be the molecular mass. That is your answer. Question 14, if you go, 1 molecule of Na2CO3 10H2O contains 13 oxygen atoms. I have marked it 10 oxygen over here and 3 over here. So 1 mole, how many atoms? So 0.1 mole, how many atoms? Next, if you have B, 14B will have this way. Sodium, it is given 4.6 gram of sodium is present. Atomic mass you know. So now 23 gram is equal to 1 gram atom. So 4.6 gram is equal to how much gram atoms? Similarly, 32 gram oxygen gas is equal to 1 mole. Now this data here, it is not given. So you have to learn and remember. I have told you many a times earlier also. Now exercise 5B, if you go through question 15, what mass of calcium will contain the same number of atoms as are present in 3.2 gram of sulfur? So find out first 3.2 gram of sulfur contains how many atoms? That I have found out. You can do this way, 6.022 into 10 to the power 22 or 0.6022 into 10 to the power 23. Now I will not suggest to go into this 0.1. I will suggest to go into this one. Now this is not given, this relation. You have to remember the relations. So 6.022 atoms have into 10 to the power 23 atoms of calcium has mass of 40. So this many has how much? Now if you go to 18, calculate the mass of nitrogen supplied to soil by 5 kg of urea. What do you do? Find out the molecular weight, which will be 60. Now 60 gram contains how many gram of nitrogen? Find out. So how you find out? From this relation. 2 nitrogens are present, so 2 into 14 is equal to 28. So now find out how much nitrogen will be present in 5 kg. Matlab, you have to find out in 5 into 10 to the power 3 grams of it. Now this is little bit tricky problem, question number 26. Now see here, you have been given with pressure, density, temperature, and you have to find out the molecular weight. Now you have never done such type of problem in class 9 also. Now we know 1 mole of any gas has 22.4 liter at ST. Now what you do? You find out the volume of the this unknown gas at ST. First apply Charles' law. How do you? Your volume is given 1 liter. V1. T1 is also given 546. Okay. And then V2 you find out. So you will be finding V2 is equal to 0.5 liter. Okay. Then go find out the volume of standard temperature. Now P1 is this. V1 you know. So find out V2. You apply Ball's law. So you find out this. Next, 22.4 liter is the volume of 1 mole of gas. Now 0.75 liter will be having mole of how much mole? So X mole is coming as this 0.0335. Original mass was 2.4 gram for 1 liter. So 0.0335 moles is equal to, this is the relation. What is the relation? Number of moles is equal to mass divided by molecular weight. So mass divided by molecular weight. So you are getting molecular weight is equal to 71.6. Now you may have certain question why we have taken volume as 1 liter. Because the density is given per liter, that is the weight. Okay. Next you have 27. This is also easy question, but still I felt you may have some problem, that's why. Find out the molecular weight. So 1000 kg, 40 rupees. So 342, how much? It's very easy one. So you do all the related problems except 19 and 31. Next session will be on the vapor density from chapter 5b and chapter 5c. As I told you earlier, note down all your doubts in your copy and discuss as soon as the class resumes. Stay safe and healthy at home.